Okay, we're here today for the second session that discusses the whole nature of science and data and theory and facts, etc., etc. I want to once again warn you about correlation and causality. Okay, before the broadcast, I was talking to people in the live section of the class. In the 1950s, almost no one ate greasy fast food because it didn't exist, right? McDonald's and Burger King, they didn't exist. And the average lifespan of males, anyway, was somewhere in the mid to late 60s. 50 years later, we consume tons and tons of greasy fast food, and the average lifespan for males is up in the 70s, mid-70s, about 8-10 years more. Conclusion, if you eat a lot of greasy fast foods, you'll live longer. Well, obviously, that's ridiculous. Or let me put it this way, there's no proof of that. I don't know how ridiculous it is, right? At least people are eating, but you understand what I'm saying? You have to be very, very careful about things like that. Okay? Did we talk about basketball players? I don't think we did. You know, there are people, there is a correlation between ethnicity and basketball skill, right? The large majority of people who are the top basketball players in the NBA are black. You know that there are people who really believe that there's something genetic about blacks being superior in basketball? If it's true, can't prove it by me. A correlation doesn't mean there's a causality, okay? Does anybody know, before the NBA, which was founded in the late 40s, early 50s, does anybody know at the time the NBA was founded, which group dominated basketball, which ethnic group? Go ahead.
It was the Dolph.
Did we talk about this already?
No.
But with ethnic group, right? Dolph Shays. And what ethnic group was he from?
He was Jewish.
Right. The Jews dominated basketball. Mostly surprised to hear that? Right, blacks were kept out of professional basketball, but the guy who forced them in was Abe Saperstein. He founded the Harlem Globetrotters, who, by the way, initially were a top team. They won before the NBA, they won the professional. Used to have playoffs with professional champs, and they won. And he had enough oomph because he was such a dominant basketball player in his days. And the founders of the Knicks and the Celtics, Red Auerbach and who were the other? The Jews dominated, but there used to be all kinds of articles. Wow, why are the Jews so much better than anybody else on basketball? Well, some of it, my guess, is for the same reason. And people are talking about genes and about culture and who knows. Well, the same reason blacks are, because Jews were poor. They lived in the inner city. There weren't too many baseball and football fields for them to play. So they played basketball. And also they tended to crowd around the way blacks' culture sort of crowds around schoolyards. Jews tend to crowd around community centers and settlement houses, that kind of stuff. And they had basketball courts. So you have to be very careful about stuff. Careful, 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 careful. Oh, dyslexia is inherited, whatever it means. Oh, really? How do you figure that? Well, so-and-so, people who have trouble reading, their children have trouble reading. It's a slight, really? Gee, I wonder why people have trouble reading and can't read with their kids. I wonder why their kids are having trouble. You think it has anything to do with the fact that their parents don't read too well, that the kids aren't reading too well? By the way, it's only a very slightly higher, right? A lot of kids who are labeled dyslexic have parents who read great. So, is that my phone? Anyway, so you have to be careful. You have to be very, very careful. I know this is bad television, but this is driving me nuts. Stupid phone. All right, before you do that. And you have to be very, very careful. We're going to get a little music here. There we go. That's me, my phone turning off. In any case, you have to be very careful about that, and you have to be very careful about correlations in general. There are some people who tell you correlations, you should probably try to stay away from them. Okay? So for instance, remember I talked about correlation. Do people who are alcoholics, parents who are alcoholics versus parents who are not alcoholics, right? Let's see if there's difference in something, but you can't randomly assign people alcoholics and non-alcoholics. So, for instance, is there a difference in self-confidence? A lot of people say, forget that. If you have a suspicion that people whose parents are alcoholics have a lack of self-confidence, what you need to do is develop programs that will raise self-confidence. And then, if you think this is a good program and it's better than the regular program, randomly divide people into two programs, do an experiment and find out. Forget about the rest. You're never going to figure it out. Now, sometimes things like smoking, there's still no experimental evidence, clear experimental evidence that smoking causes diseases. Because you can't randomly divide people. Heads you're a smoker, tails you're not a smoker. And the cigarette companies for a long time were saying, look, it's random. It's just the luck of the draw. But if you get correlations over and over and over again, and you try to rule out fact, as we talked about that, then you can say, but I want to tell you, for years there was great suspicion that drinking coffee caused lung cancer. People who were heavier coffee drinkers got more lung cancer than people who weren't. Anybody want to guess why? You drink a cup of coffee and push it down.
Have a cigarette.
And you have a cigarette. Finally, somebody had the brains to say, wait a minute, let's take a look at heavy coffee drinkers who don't smoke. Okay? In those days, it was hard to find them. But they found them, and there was no difference. So you have to be very careful. Data, 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 data. Now, after I have said that, wow, look at the color of that shirt on TV. After I have said that, and I have made all this, told you, no, everybody knows, and no assumptions, data, 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 fine, you got to know data, I have bad news for you, you can't do it. So we're going to discuss, let's go to the overhead for a minute. What we're going to discuss today is, no, not that one. I'm sorry. Let's go to the PowerPoint. My fault. Data and theory. Okay, we're going to discuss data and theory. Data and theory. Where theory comes from. Okay, come back to me. Somebody already printed these out, but who can give me a regular, by the way, the word data is plural. The data are, not the data is. Here, let me show you. Let's go to the overhead. This is Latin. Datum, data. Datum is a singular, a piece of evidence. Data is plural, a lot of evidence. As the Bayesian statisticians say, any datum is better than no data at all. The datum is, the data are. Anybody take a Latin in high school? You took Latin?
Yeah, I don't remember.
She push it down. You can say it. She doesn't want to say. She doesn't remember. This is here. Let's go back. Let's go back to the overhead. This is neuter gender in Latin. Okay, datum, data. I don't remember much myself. I didn't know much when I studied it. Okay, so come back. Okay, so who can give me a common word for data? What are data? Not what is data. What are data? What? Somebody say it. What? Push it down. Say it. Push it down. Push the microphone down.
This one?
Yeah, no, the button at the bottom.
The green one?
The one that says push. Long.
This one?
No, at the bottom. At the bottom.
Right
There you, yeah, there you go.
Oh, data are facts.
Facts, findings, observations. Okay. So let's try this. We're going to take a vote. You have to vote. I'm going to make a statement, and you're going to tell me whether that is a fact, a datum, or whether it's a theory. The Earth is in a solar system. The Earth is one of the planets that are going around the sun, and the sun is basically stationary, and the planets are going around it in orbits, elliptical orbits. Is that a fact or a theory? Who votes fact? You have to vote. It's a fact that we have a solar system. Raise your hand if it's a fact. Who thinks it's a theory? About 50-50. Those of you who thought it's a fact, I'm going to prove to you right now that the Earth cannot be moving. Cannot be moving. The Earth cannot be moving. From the observations, from the data that we have, the Earth cannot be moving. I'm going to show it to you. Okay, now the first thing we have to do is a fact. The constellations don't change. I'm going to stand up, okay? Ready? The constellations don't change. I'm going to be moving too. In other words, the stars are in the same position relative to one another during all the seasons of the year, right? You draw a sky map, it's good 12 months a year, right? You don't have stars wandering and changing places in the sky. They're there. That fact. Now, sometimes in the winter, you can see stars you can't see in the summer, and vice versa, just below the horizon. But that fact, it's an observation, is proof positive the Earth is not moving. And I'm going to show it to you. Okay, you come and be the Earth.
We did this last week, you know.
Oh, we did this already?
Yeah.
Oh. Okay. Now, explain to me then why. We did this last week? Man, I got to start writing stuff down. Explain to me why then you understand, in order for it to be a fact, we have to observe it, see it. Nobody's seen it. Nobody's out in space seeing it. It's a theory. Do we ask whether gravity's a fact or a theory? Gravity's a theory. It's an explanation. So data, here, let's go to the PowerPoint. Data are the facts, and theory is an explanation of the facts. It attempts to explain why the world is the way that it is, why we observe what we observe. And here's the bad news I have for you. Come back to me. I did this already? Man, I'm getting old. Here's the problem that we have. Despite the fact that I've said data, observations, doesn't work. Because you can't start from nothing. Right? You have to assume something to prove something. I'll give you an example from math. Who took plane geometry in high school? Just about everybody here. Did anybody take it twice? My hand's up. You took it twice? Did anybody take it twice in high school? She's saying that. Did anybody take it 3 times? I'm always the winner. Okay. Now you remember the password of plane geometry. Proofs, 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 proofs. You have to prove it. But you can't prove something from nothing. We didn't talk about this last week, did we?
No.
Thank God. Getting old. Okay, look. In every system, when you start out to prove something, either intellectually you do in plane geometry or by gathering data, you have to start from somewhere. So what's just there in plane geometry? What's just there? What? Push it down. What's a given? Tell me what's a given in geometry. The things that are a given in plane geometry.
Postulates that are accepted as true.
Well, wait, before the postulates, what's just there? The plane is just there. A line is just there. A point is, some say, yeah, a line is a moving point, but a point is just there. And then there are the postulates that, remember the beginning of the book, the 10 basic assumptions you have to make. If you don't make this something, I'm going to prove anything. You can't prove something from nothing. Who passed plane geometry? Anybody? Yeah? Who passed plane geometry in high school? You took it in college, I heard you. Okay, what are the 10 basic assumptions? Who remembers one? Anybody remember even one assumption of plane geometry? If you're a math teacher, I don't want to hear from you. Anybody who's not a math teacher? Go ahead. Push it down, push it down. Come over here then. Come sit over here. What's the matter with you? I'm friendly. All right. All right, here he comes. He's moving to a microphone. There he is. See, a long journey. Okay, push it down and tell me.
A line consists of 2 points.
One and only one line can run between any 2 points. You didn't remember that, did you? Who knows another one? I know another one. Parallel lines never cross. You don't prove that. Let's try this. I'll make you the deal too, but you have to email me if you're on the day after the tape. You can't wait. How many people here will be ready to take a high school test in plane geometry? If you pass it, I'll give you an A for the course. If you flunk, I'll give you an F for the course. Anybody who's not a math teacher? What do you teach? Push it down. Push down the thing. Oh, you don't have a microphone? She said she's a science teacher. They don't count. Math science teachers, I don't count. So obviously, it's very, very important for us to teach things in high school because kids have to know knowledge that when they get into college, into graduate school, they don't remember it anyway. When I'll give you a hint. When two lines cross, the opposite angles are equal. I think you can either assume that and prove something else, or prove something else, or assume something else and prove that. I can't remember how it works. Degrees, all this kind of stuff. Then you start. You got to start from somewhere. So you can't start from nowhere. Who was I picking on? Before I come over here, come over here. Oh, we're going to stand up. I see something strange about you over here. Come over here. Name?
Laura?
Laura? Laura, here, Laura, hold up your hand like this. No, the other one. What's that thing on it?
A watch.
What's that thing?
A watch.
What does a watch do?
Tells the time.
Time? What's time?
It's the passing of seconds and minutes and hours.
I thought, so seconds and minutes and hours are time? Yeah, can you define a second for me?
1/60th of a minute. No.
We got a little circular definition going on here, right? So minutes and hours are the passing of time, right? But what's time? Passing hours, minutes. Anybody? Can anybody help her out? What's time? Oh, push it down. Push it down.
Passage of light.
Of light? So from a dark closet, time doesn't pass? If I'm in a place where there's no light, in a cave where there's no light, time doesn't pass? Sure it does. Okay, Laura gave the best definition we have. There is no, thank you very much. Give her a big hand here. Thank you. All right. Look, face it. There is no definition of time. We measure, but we don't have a definition of it. Come back to me. There's no definition of space, mass. They're just there. Energy, they're just there. Right? They're just there. You can't start from nowhere. Okay? So physics starts from, so physics is our most advanced science. It's been around the longest. So you follow scientific method. You start to gather data, but you assume things like mass and time. And of course, what Laura was doing, what I was saying, she tried hard, right? That's the best answer I've ever had. But in the end, if you can define it, so you can say, let's say, oh, I have a definition of mass. It's particles. Collection of particles. Good. So what's a particle? Oh, I know what light is. It's a bing boing and two fladiddlenakers. Terrific. So what's a bing boing? In the end, you got to start from somewhere. And not only do you have to start with stuff, but you have to start with certain basic propositions, like the 10 in math. Now, math really is not a science, because when somebody told the mathematicians who did plane geometry, the Earth is not a plane, and they said, we don't care. Get away from us. We're just doing theoretical mathematics. Get away from me. By the way, if you ever want to do a short doctorate, just to show how math is not a science, do it in theoretical mathematics. One of my cousins, or it used to be my cousin, I want to give him a whole family history, right? He did his doctoral dissertation was 3 paragraphs, or 5 paragraphs of incomprehensible English, and then only about 12, 15 pages of squiggles. He said, "Here, read this." I said, "Oh, this is." I said, "What the heck is this? What is this?" He said, "Well," he said, "this is the mathematical formulation for turning a hollow ball inside out without cutting it, like a tennis ball, turning it inside out without cutting it." So I scratched my head. I said, "I don't think you can do that." So he looked with a look of disdain, like, What are you, a dope? He said, well, of course not in the physical world. That was the whole point, to invent a theoretical mathematical world where it could be done. So, I said, now I get it. This is brilliant. And, this is... See, but science doesn't do that. Science is trying to find out rules about the real world. That's one of the criticisms, by the way, of economics lately, that it relies on hypothetical formulas that are lovely and brilliant, but they don't predict well people's real economic behavior in the real world. And then it's not a social science anymore. Say it
They're
again?
taking statistical and probabilistic models and then using that to infer.
Right, that's
their
right. Well,
results.
the point is mathematics can be used exactly by scientists in order to explain. You saw Newton used... Newton invented calculus to explain what he knew. He and Leibniz, right? Most of the evidence said they did it independently. But that doesn't... But in the end, it has to be for this world. Now, when science started, people made different assumptions about the nature of the world. Let's take physics. Physics was all over the place. We had one physicist over here, she's mucking around with dropping balls off a tower. And another one, he's looking at planets. And another one is staring at the sky. And another one is watching water flow down the hill. And another one is messing around with electricity. And another one has magnifying glasses. And another one's... It was all physics, but it seemed completely unrelated. Like, this psychologist is worrying about how you think, and this one's worrying about your behavior, and this one's worrying about your emotional state, and this one's worrying about your family relations, this one's worrying about how you act in groups. It seems all over the place, right? Right, it does. But it's vaguely talking about, and physicists were all over the place. And what happened is that the underlying assumptions they made, let's go back to the overhead. They had, I'm sorry, to the PowerPoint, you knew what I meant. Theory. Theory is an explanation of the facts. It attempts to explain why the world is the way it is, why we observe what we observe. And what we had, come back to me now, thanks. So what we had was some physicists observing, saying, well, I've observed this in my optics, and if you assume A, B, C, and D, it explains all the data. Other physicists said, oh, well, I've observed this. I've been observing something else. I better get this off the table where the computers are. It makes me nervous. I've been observing something else. I've been watching the planets, and if you assume X, Y, and Z, but D can't be true. Otherwise, it contradicts. So they were all over the place with contradictory theories, et cetera, and often contradictions within the same field. Right? I'll give you an example. For a long time, physicists said, look, rest is the natural state of the world. This is an assumption we're making. We can't prove it, but look, things at rest tend to stay at rest and something acts on them, and watch the pen, and things in motion tend to come to rest. Rest is the natural state of the world. That's what it is. That's how it is. Along came Galileo, and he said, you know, I'm gonna do some other observations. So he took a track, right? A contained track, you know, and he took a marble and he rolled in it. And as long as he made the track, the marble kept rolling and rolling and rolling and rolling, right? He said, gee, if I made this track infinitely long, the marble would roll forever. Well, he wasn't quite right, but he had the idea. And then he went up to northern Italy, where there's ice. Anybody ever been up there? My daughter was there for a while. She said it's magnificent, Como and all those places. And she said, and he took a flat stone or a hockey puck today. I'm sure he didn't have a hockey puck in those days, but and he pushed it on the ice, and the thing just kept sliding on the ice all the way until the other side of the lake. He said, you know, if the lake went on forever, the stone would slide forever. So he said, here's his evidence. He said, I don't think that you're right. I think things at rest tend to stay at rest unless something acts on them, but things in motion tend to stay in motion. And there were huge fights about that and how it is and how it is. But of course, what's the first question you have to ask Galileo? If things in motion tend to stay in motion, what do you have to? What's the first question he has to answer? Push it down and say it. Come sit where there's
Why
a
does
microphone.
it stop?
He said, why did it stop? Why did this stop? Was this right? Now, if you were to ask the people from the old physics, Aristotle's physics, they would have said, what a stupid question. You're wasting your time asking me that question. I told you everything comes to rest. That's a fundamental assumption. Galileo had to begin doing experiments and explorations to try to figure out why this came to rest. Why when you push things, they come to rest. So the assumptions you make determine the kind of research you do. Let me give you an example from psychology. Some people assume that individuals are externally motivated. They're motivated by things in their environment. And other people say, I don't think so. I think people are internally motivated. So the first one say, you see, okay, every time that person turns to the right, I give him $50. Before you know it, he's going like this all the time, right? The second people say, oh, very nice. But did you ever see a little baby? Crawling around, getting into everything, a toddler, exploring things, opening things up. Nobody's rewarded them, they just do it. So I think they're internally motivated. So the question for the first people of how do you motivate kids is a real question. People are interested in, what do I do to get kids motivated? They do a lot of research on that. For the second group of people, it's a stupid question, it's a waste of time. It's a waste of time. People are motivated. So how come people are motivated? Here, let me give you a picture of myself the first time I took geometry. This is an imitation of me as an adolescent taking geometry. Help me here. Okay, I barely passed. I don't know how, but I did. Okay. The second people, what are they going to? What are they going to ask? What turned him off? What turned off his natural motivation? I don't look for ways to motivate. I learn for ways to keep natural motivation from being suppressed. We're going to see that when we get to the humanists. So it's a very difficult, it's a question that you have to, the assumptions you make a big difference. They tell you what to look for, what to explore, etc., etc. Now, something interesting happened in physics. Along came a guy named Newton, Sir Isaac Newton, and he said, you know what? I have a set of assumptions, and if you make those assumptions, they'll explain everything. Newton's laws of mechanics. For every action, there's an equal and opposite reaction. He didn't prove that. He just said, if you assume that's true, and if you assume that, then everything's okay. Okay? I have a comprehensive theory of physics. It explains all of physics. We don't have a comprehensive theory of psychology yet. We don't, for two reasons. Number one, we haven't been at it as long, and we may never have one. As the physicists have, they've been at it for hundreds of years. We just started 100 years or so ago, maybe a little longer. And number two, our stuff is much more difficult than the physicists. You don't believe me, do you? Look, if you're trying to make laws about carbon atoms, or you're trying to make laws about helium atoms, or about hydrogen atoms, I know one carbon atom is different from another one. That's what they tell us later. But not nearly as different as one person is from another, right? When we make laws about all these different personalities, it gets tough. But we try. Okay? So we're where physics was beforehand. We have different theories, we have observations, different theories, and often we have the same observation with different explanations. For instance, anybody had any experience with token economies? That's what a token economy is in a school. Oh, did you do it in your school?
Did I?
Yeah.
Did I practice it?
Push it down, push it down. Yeah, did you do it?
Did I practice it
Yeah.
or did I use it?
Did you use it, or
Yes,
was it
I've
used on you?
Yes, I've used one before.
Used when you were a student?
When I was a teacher and when I was a student.
Both. Okay, so tell us how they work more or less.
The student does something to deserve a reward of some kind, and the teacher gives them, like, I used a ticket system where the student received a ticket for doing something according to what they were asked to do, and then they did a raffle later. It's a reward system.
A raffle? Usually you can buy something. How did you decide what was raffled off?
Whatever I had money for
What?
at the time, whatever.
Oh, so
I
you
had
did it
money
yourself.
for.
In
Yeah,
in the original ones, the kids, actually there was like a store. The original one that was done, there was a store. And the kids there were prices, like for the tokens or for the tickets, so many tickets for this, so many tickets. And the kids kind of decided what was going to be in the store. Like there was nothing there about, a math workbook, right? You want to buy that, right? And so it worked. The kids did a lot more work. Said, see, I told you tokens worked, said the people who were pushing reinforced reward economies. Along came the social psychologists. And said, well, you're full of baloney. That's not why it worked. It worked because the kids were doing it together, moving together and deciding together and all this. And it was a group project, and that's what did it. Okay? Along came the developmental psychologist and said, I'll bet this works better at some grade levels than at others. And it does. How do you figure that? Maybe the understanding of what's going on here, rewards, and what they are and what they mean, etc. How old were the kids you did it with?
5th grade?
5th grade. Yeah, it works pretty well in 5th grade. You try to do that in middle schools, works less. Oh, you're brown-nosing for a ticket, huh? You're kissing the teachers, you know what, for a ticket, huh? Especially with boys. I don't know about the other side of the gender line with boys you didn't. So it depends what the values are. So on and on it goes. And Kohlberg will tell you, I knew that. I knew that would happen. So different people have different explanations of why. Developmental psychologists will tell you it depends on the person's understanding of the role of authority. The more they invest, and this develops. Young children invest a lot of power in authority. As you get older, you like authority less and less. So you finally become an adolescent, you hate authority, right? So it depends. So you have different explanations for the same data, for the same things that we find. So let me summarize this. Let me try to go it here. Let's go back to the PowerPoint. Okay, the first thing we say, let's do it backwards. Theories explain data, okay? Theories attempt to present a coherent picture of the universe. A theory is a model of a part of the universe. The solar system's a model to explain why we see all this stuff moving through the sky and what's going on. So we just, come back to me for a second. We just stand here and we watch the things and we make models, and it's a part of the universe, right? Okay? Now let me show you something, okay? I'm going to show you, let's go to the overhead. I'm going to show you 2 models that explains the movement of the planets through the heavens and the moon and the sun, right? One says the sun is in the center and the planets are going around it in elliptical orbits. You see it? Those are supposed to be ellipses. The other says, no, wrong. The Earth is in the center. The sun's going around every 24 hours. The moon is going around every 29 and a half days. And the planets are going around in perfect circles. And the planets are going around in circles too. The problem is, so this is the problem, this is supposed to be a circle. This is the orbit of Venus. The trouble is, if you measure Venus here, when it's supposed to be back there, it's only over here. Right? It doesn't, it seems to drag in its orbit. So the people who made up this theory said, oh, wait, we know what's going on here. Every once in a while, this is the theory of Copernicus and Kepler. Copernicus was still stuck with the idea. See if you can get my picture in the corner there. Okay. Copernicus was still stuck with the idea that the world was composed of perfect circles. The planets had to go around in perfect circles. And when it didn't work, he said, well, get better measuring instruments. Kepler said, I don't think it's circles, I think it's ellipses. Okay? This is the old model of Ptolemy. Right? And Ptolemy said, oh, I'll tell you what's going on. Every once in a while it goes in its orbit, and then it makes a perfect circle What did I do here? It makes a perfect circle in its orbit, comes back, and then keeps going. See, it just does this. Wait a minute. I'm going to have to erase here. It's driving me crazy. It just does this. Just goes, and it makes a perfect circle, and it comes back. See, this is supposed to be a circle. You have to bear with me. And then it keeps going, and so on, and we have these circles, and that's the orbit. Here's the next planet going around like this, and it makes this circle, right? These circles in the orbit, and it just keeps going, and it makes the circle in the orbit, and then it comes back, and it just keeps going. All right? You got it? These both explain it perfectly well. Come back to me for a second. And if we got Ptolemy out of his grave and said to him, listen, we've had some more planets, okay? We've had some more planets since you died. He said, no problem. Show them to me, okay? So here, go, right? Go here. Come back here to the overhead. He'd say, oh, you found Uranus here. Here's the orbit of Uranus, all done. By the way, come back to me for a second. I was teaching this course, and somebody said to me, you're not supposed to say Uranus. It sounds bad. We've changed the pronunciation to Uranus. I don't see that that's an improvement, frankly. So if you're a science teacher, what do you say, science teacher? You say Uranus or Uranus? Uranus. Good for you. I'm going to keep saying Uranus. She doesn't have a microphone, so I'll just... I don't get it. Political correctness can drive you out of your brains. In any case, you're not supposed to say handicapped. You're supposed to say disabled. I like the word handicap better. Disabled means disabled. You don't have the ability. Handicap means there's something holding you back, but you can do it like a handicapped course. But of course, we still have handicapped parking. I don't get it. Oh man. Anyway, you'll notice that I'm not very politically correct. Okay, let's go back to the over. See if you can get my picture, that'll be good. If not, oh yeah, I see. It'll block it out. That's why you're not doing it. Okay. If you're going and you're having to study physics, which one of these models would you prefer? Which one? Which one would you prefer to study? You got to pass the course. Is this erase too? Oh, that erases too. I'll be darned. Which would you prefer to study? Come on! You're going to have to take a test on this or on this. Which would you rather take a test on? Copernicus. We'll push it down? Copernicus, why? Why? Be honest.
Because that's how you raised and taught.
Because why? Push it down, push it down. Because why?
Okay.
Come on, you got to take a test. You don't give a damn about physics. You just got to take a test.
That's what you're raised up to see, to know.
No. It's a few hundred years ago, and you got to decide which one.
Yeah.
It's easier. What are you nuts? Come back to me. That's correct. If you have two models that explain something equally well, you pick the one that's easier. That's called here parsimony. When you see somebody trying to parsimony bowl you over with fancy sounding gibberish and fancy diagrams, you know, and there's a much easier explanation, stop listening. Okay? These are the characteristics of a... Can you see this? Yeah. Characteristics of a good theory. I found another eraser here. Those guys owe me. Of a good theory. Okay? The second one that we're going to talk about is compatibility. Okay, come back to me. I know I don't have a PowerPoint for this, so it's good you're in class. If you have two theories that explain things equally well, theory A is compatible with a whole bunch of other explanations you have, and theory B contradicts it, pick theory A. Let me give you a little example here, my friends. Everybody says, scientists, they won't accept extrasensory perceptions, the mind's ability. They're just bigots. Okay, you see this pen? Watch. Watch this pen. Can you see it on here? Watch it. I'm going to move it with the power of my mind. This table won't move. Okay? I do it with the power of my mind, the pen moves. If that's true, if I can do that with the power of my mind, all of physics has to be junked. Has to be junked. And a good scientist will say, okay, if you really can do, because there's not enough, you can measure the energy coming out of a person's brain. There is not enough energy coming out of a person's brain to move this thing across the table, or what some of them do, have things flying through the air and all that stuff. If that's what you observe, then it's junk. Modern physics is junk. We have to get rid of it. We have to make new theories. That's why physicists are very, very reluctant to say, okay, in this area, all the theories of modern physics will go away, but they're very reluctant. And people have all these powers. If you can take your fingers and go like this, you ever see people who have extrasensory perception, in quotes, do like this, and they're rubbing a spoon and the spoon breaks in two? If you can do that, there's something wrong with our understanding of mass, of the relationship of mass to energy. Because just by doing this, you can't. There's not enough heat to break the spoon in two. So you have to give me evidence. So when I do a test of extrasensory perception, I have to have people with three areas of expertise. I want a psychologist in there. I want a physicist in there, because some things that look like, ooh, are just physical principles. And what's the third area of expertise? Come on, think about it. This person is going to be in there to see whether you really rub this pen and broke it in two with your fingers, or whether it's a bunch of hooey. Come on. A magician. Anyone who does any of these extra power stuff without a magician in the room, people take and throw it in the garbage. They don't want anything to do with it. You have to have a magician there. And so far, no one who claims to have extrasensory powers has been able to do anything that a magician cannot do. And no one has been able to demonstrate extrasensory powers with a magician in the room. There was one in the old days when the Cold War first started to thaw. Remember the Soviet Union? I'm glad it's gone. I don't know about you, but in any case, so there was an exchange when it began to thaw. There was an exchange of publications, and one was called USSR, and on the cover was a woman who could read with her finger. She was blindfolded and she was reading with her finger. This was a great achievement. So an American magician took a look and he said, I know how she does it. They said, how? He said, here, I'll show you. They took dough, cookie dough, pizza dough, slapped it on his face. He said, here, put it on my eye. And then he tied a handkerchief around and he drove a car around the corner. They said, how did you do it? How did you? He said, I'm not telling you. We just don't tell how they do it. I said, it's a trick. It's a trick. It's all tricks. And scientists are very glad about that. Because if it turns out not to be a trick, then we have to junk modern science because it's not compatible with all the rest. And finally, let me just give you one more. Let's go to the overhead. A good theory is heuristic. Okay? It helps you find things out. Okay? A good theory helps you find things out. Let me give you an example. Okay? A long time ago, Neptune was jumping in its orbit. It seemed to jump in its orbit. I think it was Neptune. It's either Neptune or Uranus. I think it was Neptune. Okay? So, it all of a sudden went out of its orbit. So let's go back to the overhead. Okay? So if you told that to Ptolemy, he said, oh, it jumped in its orbit here. Dun, 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 dun. All fixed. Right? But this model is now seeing itself as having to be compatible with Newton's physics. This model is compatible with Newton's physics. This one's not. Planets don't just all of a sudden say, I think I'll take a little trip in a circle for no reason. So these people, let's go back here, let's wait, stay here. So these people said, gee, I wonder what's going on out there. Did I erase that? Forget it. By the time I find that, the class will be over. How did I erase that? These people said, we've got to find out what's going on. Now I've got to find out where the undo button is. Oh, here it is. I have to find out what's going on, okay? And so they said, come back to me, so they said, aha, here, I'm going to stand up. They said, aha, something must be making it move. Because things in motion tend to stay in motion, and something acts on them. They were, all of a sudden, it got out of its plane of motion. So they said, it's probably not a giant electromagnet in the sky. It's probably another planet. So they looked and looked, and they found Pluto. And they had theories. By the way, Pluto's a weird planet. You can draw the solar system on the palm of my hand, right? Here's the sun, and you can draw it like this. The planets go around, except for Pluto. Pluto's going like this. It's out of the plane of the solar system. Solar system is like on a plane, except for Pluto. That's why a lot of people think it was just a piece of space junk that was wandering by that the sun's gravity captured. Okay? Interesting enough, by the way, I want you to know. You think Pluto's the farthest planet from the sun? Not now. Go ahead.
Choron.
No, never mind. I don't know. Is there another one? I don't want to hear about it, okay? I got enough trouble. Right. Pluto's orbit sometimes dips inside of Neptune's. Is there another planet they found? Push it down.
They're not sure if it's a planet or if it's a moon of Pluto.
Oh, very interesting. Very interesting. Right now, you are privileged to be living in a time when Pluto's orbit has dipped inside of Neptune's. It happens, I don't know, for 30, 40, 50 years, I don't know, in every few hundred, so you're living in a special time. When the moon is in the 7th house. Anyway, you get the point. Okay? So that's what makes a good theory. Here, I'm going to sit down again. Now, in psychology, let's go back to the PowerPoint. I'm going to try to keep this straight. In psychology, psychological theories present models of thinking, behavior, and emotions. Okay? Okay, and every theory begins with assumptions that shape its explanations and guide research. Okay, come back to me for a second. Okay, look. There are some people who will tell you psychology is the study of behavior. How behavior changes, how it shapes, what models behavior, right? Other people tell you, nonsense. You don't know anything about behavior, okay? A person is crying. So, what are some reasons that people cry? That's the behavior, crying. What are some reasons people cry? Help me out here, this is television.
They're hormonal.
What? Say it again.
Said they're hormonal.
People can cry for no reason at all because of some body chemistry. That's right. That's the first time I ever got that answer. That's a damn good answer. Other reasons people cry. What? Say it again. Louder. Oh, you got a microphone. You lied to me. Yeah, why would a person cry?
Being broke.
Broke.
This year's
Being
tuition.
Upset, right? Another reason people cry. Go ahead.
Because they're happy.
Happy! Everybody cries at a wedding. Finally got one of my kids married. I couldn't stop crying. Right? Happy. Any other reasons people cry? Hurt. People got physically hurt. Come on, there's another one. You all know that one. Julia Childs, she just passed away. Right? All right? Go ahead. Say it.
They're sad.
They're sad. Come on. Why would Julia Childs cry on TV? Go ahead.
Someone else said it, but cutting onions.
Peeling an onion, right. So these psychologists say, what are you, nuts? You can measure tears and the behavior down to the millionth of a drop, but you have to know why. You have to know the emotions. Other people say, you ruined it for me. Maybe it's not emotions. Maybe it's something physiological. Right? By the way, that's not the only one. Wind gets in your face and you cry, right? Tears come out. So you have to be careful. Other people say it's thinking. So the assumptions you make about what's the nature of a person guide the research you do. Now, wait. Don't go back here yet because Okay. Now, what does data have to do? What do data have to do with all of this? What is the purpose of data? Let's go back to the PowerPoint. Okay. Data tests theories. If I have theories, data tests them. Okay? A theory is a model of A model of part of the world. Data can provide support for a theory by confirming the theory's predictions, supporting the model. Right? Do you understand what I'm saying? In other words, let me give you an example. Come back to me. I have a model of the word that says human beings tend, right? I have a theory not to function well under pressure. Do we talk about this? Under pressure. When you're under extreme stress, they don't, under stress, humans don't function well. The more they're stressed, the worse they do. Okay? And I go in and I get preliminary evidence. People who come in freaked out about a test. Who freaks out about tests? Anybody in here? A few people. It tends to reduce their performance if they know they're being tested. But then somebody came along and said, I want to find a person who comes into like this. I'm cool, man. I don't care about this test one way or the other. Just give it to me. I don't care. Everything's cool. Everything's fine. I'm happy. Those people don't do very well on tests either. So that model of the relationship between stress and behavior turned out you have to be modified. Okay? Has to be modified. Because it turned out that with no stress at all, people, they didn't care. They didn't do anything at all. So let's go back to the PowerPoint. So data can provide support for a theory, or data can require us to modify or discard a theory, modify or discard its assumptions, because the data do not confirm the theory's predictions. Not the data does not, the data do not. Data plural. Okay? You got that? Okay, come back to me. We're going to go back here. Okay? So, while it's true that we can spin theories, the theories are always trying to explain data. Theories are also heuristic. Theories give us ideas of what to do. If I have a theory that says people are this way and that way, it gives me an idea of what to do. Right? A good theory gives me ideas of what to look at. I'll say how to look at things. For instance, for a long time, I'll tell you, I'm sympathetic to people who think kids should have choice. And they set up schools that have choice. Then you go into regular schools and say, okay, choose, and the kids freak out. Well, they had to modify their idea about choice. That the ability to make choices is a function of, if you've been told you can't make choices, you kind of lose the ability to make a choice. Something that they didn't believe at all. When you would go to school where everything is programmed, all of a sudden you say to a kid, okay, go to one of 7 centers, you pick your own, the kids didn't know what to do. They've been told what to do for so long. This is 3rd graders, 4th graders, right? Even 2nd graders. So you have to modify based on what you find. And sometimes you just have to discard what you're doing. You just have to discard it because it just doesn't work.
Heuristic can be a gut feeling.
Heuristic what?
Gut feeling. What do you feel like?
No, it's not only a gut, it can be a gut feeling, but it's because it's an idea that you came up with, but it comes from understanding the principles of the theory. Okay? So for instance, when people who said people are humans are internally motivated began to see people not motivated, it was clear to them that the research had to be what turns people off. We have to look at that. If we find out that nothing turns them off, then we have to change our ideas. So far they haven't. And so you try to get maybe gut feelings about what may turn people off, but you have to research them consistently. Okay? So, let's go back to the PowerPoint. So every theory begins with underlying assumptions that shape its explanations and guide research. Okay? Because, again, you have to start somewhere where you're researching, when you're researching. and, let me do that again for emphasis, and, like that effect? I got better ones. I got a new one. These differing assumptions about people have a profound effect on the kinds of research psychologists do and on the educational practices they advocate. The research and on the educational practices, whatever that is. Education being defined broadly, right? Let me give you an example. Come back to me. Okay. If you want people to change their eating habits, and you try to tell them, look, if you don't change it, you're going to die. That comes from, oh, we have the dietitian here, right? That comes from an assumption that people respond to fear, and that fear will do it. Okay? Now, most of the research shows, okay, I'll give you a personal example. My father didn't start smoking until he was about 30. Don't ask. Most people start when they're teenagers. He smoked for years and years and years, a lot, 3 packs a day, and the doctors began to tell him, you better not do this, you're going to get sick, you're going to get cancer, you're going to get this. When he was 63, he went for a physical exam. The doctor said, you're okay. He came back home and he said, I'm having chest pains. His wife said, I'm calling the ambulance. No, I was just at the doctor. He said, I'm calling the ambulance. Called the ambulance. He said, I don't think it's anything. It was just at the doctor. It was literally the day of his physical exam. It was the strangest thing. She calls the ambulance anyway. In the ambulance, his heart went into fibrillation. If the EMTs hadn't been right there, he would have died. He said he was going black, he didn't remember anything, and all of a sudden, the next thing he remembered, he heard somebody go, "Ugh." At the same time he heard the words, I'm allowed to say this because it's a quote, breathe you son of a bitch. And he got up, and there's this guy, it was the cardiologist, pounding on him. Okay? My father never smoked another cigarette, in case you haven't figured that out. He lived another 23 years, too. Right? He lived to 86. He lived at ripe old age. So people said, now, so there's a theory here about what's the relationship between when people try to scare you and real event scares you. Right? We know, for instance, that shock therapy works to stop smoking. People take a cigarette, give them a shock. That was the old Schick method. You laugh, you can't do it because I'm politically correct anymore, but it worked. However, it doesn't work for overeating. Not for all kinds of overeating. For some people it will, for some people it won't. But if you're going to try to scare people, then you have a theory about the nature of fear as it functions with people, especially verbal fear. Okay? There are many people for whom it is very important not to be heavy because people look down on people who are overweight. Other people just don't give a damn. As a matter of fact, I know someone who says, and he really means it, he says, what am I giving into all this Hollywood crap for? That's a quote, so I can say it again. He said, what's the difference? If the doctor tells me, and his blood pressure's fine, and his triglycerides are fine, and his diet sugar is fine, and his cholesterol, I don't care. And he really doesn't. And he has a nice wife, a nice kid. He's fine. Well, there are people who will tell you that we have to look at the nature of, to whom is it important? Why is it so important to some people to conform and other people not to conform? What is the nature of the development of emotions and the development of your role in society? We're going to see a lot of theories who say that, right? And if you need to understand, and if he really doesn't care and you really want him to lose weight, you're going to have to come at him in a different way, right? Do you understand what I'm saying here? What you think? Some people will tell you, All you've got to do is get a situation which people are not conform, where not to conform, right, will force people. Other people will tell you that's not true. Who conforms? Who doesn't conform? Under what conditions do people conform? What's the relationship between behavior and thinking? For a long time, people thought if your thoughts change, your behavior changes. Right? In other words, if your ideas change, you'll change your behavior. Okay? When your ideas change, when your attitudes change, you'll change what you think about certain things. So I'll give you for instance. That's why people who said that said, forced integration in the South is a waste of time. We can't do integration until we get people's prejudices to go away. Then along came a group of sociologists. They said, no, we have a different theory, that circumstances change attitude. They said, we're going to integrate the schools and we don't give a damn. Right? Now, people tested this, and sure enough, years later, it turned out to be true. They were right. Their theory was right. You came in the 1980s, 20 or 25 years after, and you asked people who had lived in places where schools have been segregated, where schools had been segregated, now were integrated, you want to resegregate the schools? The vast majority of people said no. They didn't think it was a good idea. Attitudes had changed. The vast majority said, you can't do that. Surprised? It was well over 80%. Surprised? Well, it's true. And these things make a difference. So it turned out the other people had to start discarding their theory. Right? They had to start modifying their theory. So theories make a difference. Let's go back to the PowerPoint. And because of these different beginning assumptions that people make, are people internally motivated, externally motivated, et cetera, theories present very different pictures of what human beings are. They have very different assumptions about the basic nature of people with regards to such questions as, is what we're going to be exploring, maybe not with every theory directly like this, but we'll touch on it all. What's the relationship between learning and development? I'll get back to that one. What motivates people? There are some schools that say, see if you get my picture in there now? Oh, never mind, this is good enough. There are some schools that say, look, we've got to find ways to get kids motivated. Other schools say, just let kids explore what interests them. They're self-motivated. There aren't too many of those, but there are some. Okay, let's go back to the PowerPoint. How important is behavior? We already talked about that. Some people say behavior is everything. Some people say it doesn't mean anything. How important is thinking? There are some psychologists who say, I'm not interested in it. Some psychologists say, that's all I'm interested in. Some who say, you can't really understand it without looking at emotions and behaviors, etc. Are people active or passive? We'll get back to that one. How important are emotions? How do people change? Okay? Okay, first, let's go back to the first one. What's the relationship between learning and development? Okay? Come back to me now. Some people say you develop by learning more and more and more. As you learn more, you develop. Other people say, oh no, that's just not true. As you develop, as your thinking develops, that enables you to learn more and more. And in fact, what you learn when your thinking is primitive is stupid. You have to unlearn it or change it. That's what Piaget thinks. I happen to agree with him. It's not stupid, it's just, he wouldn't use the word stupid, he would say primitive, not adaptive, it's not good thinking. And of course, what those people are going to tell you is, until you've developed to a certain place, it doesn't pay to teach somebody something. You're wasting your time. If somebody thinks there's more fingers on this hand than on this hand, and now says, whoops, I changed my mind, there's more here than here, you're wasting your time teaching that person how to add, or worse, you're making things very bad. Okay? So all of these questions are we're going to have to answer with regard to theories. Let's go down here. Okay? There's also the question of what should educators be trying to achieve. For each theory, we need to ask, what educational goals are most consistent with this theory? What educational methodologies are most consistent with this theory? And according to this theory, what is the purpose of schools and education? These are questions that we tend not to ask. But when we have enormous fights about standardized testing, these questions are in the background. I can tell you what, I'm opposed to standardized tests, I'll tell you that right now. Because I don't think that the purpose of school should be to have every kid learn the same exact thing. There are going to be some people who are going to tell you teachers need to determine what kids need to learn to pass on the most important aspects of our culture and and the things people need to know to function in society. Other people tell you that's absolutely wrong. What you need to do is let kids pursue their interests. And if they pursue them in a meaningful way, they'll learn all that stuff. If a kid wants to pursue her interests, I'll tell you in a second why I looked at my watch, then let her do it. If she doesn't know how to read, well, she's going to learn how to read to do it, etc. We'll get there, okay? I will give you a little hint now. There is no theory, I will say this at least 15 times during the course, that says everyone should learn the same thing in the same way, at the same pace, and take the same standardized test on the same day. No psychological theory agrees with that. Because people are different from one another. But when you're out there teaching, when you're out there dietitianing, when you're out there counseling, when you're out there psychology, doing all this, and when you're out there administrating, those questions should be foremost in your mind, right? And I'll give you an example with a little joke. People who eat well don't live longer. It just seems that way. You get up in the morning and you have a tofu salad. Then for lunch you have cottage cheese. And then for supper you have bean sprout salad with low-fat yogurt. He says, is this day over yet? Please help me out. It seems like it's been 1,000 years, right? Some people will tell you there are some people who have an attitude when it comes to health that if people are going to suffer so they'll live a year less, it's worth it. That's true. No, that's true. We know that all the time. There are no revive clauses. If I'm going to live longer and not have my capacities, I don't want to live. Don't revive me. That's not so funny anymore. There are some psychologists who will tell you this person is suffering so much with this thing, leave her alone. Right? There are some doctors who say, I got to treat the disease no matter what. And others who will say, I had a friend. He died from leukemia. He went through a thing of chemotherapy. Now, this was many years ago. He said, I'm not doing it again. My life wasn't worth living when I was taking those drugs. Now the drugs are they're still bad, but those were the horrible times, right? He got it again and said, I'm not doing it, and he died. Well, there's a big debate over that. Okay? What your purposes are. The same thing in education. How many people think that it is absolutely crucial for kids to know how to multiply? The multiplication table. That this is one thing that's very, very important in education. Who thinks that? Raise your hand. Kids know how to multiply. What are you, nuts? You don't think so? Who thinks it's important? The kids ought to know how to multiply. Okay, here's my kid. Here's my kid. Can't multiply. It's the 8th grade. He can't multiply. Tell me your name, kid.
Amir.
Amir? Class, this is Amir the stupid. This moron can't even multiply, and it's the 8th grade. Amir, I got news for you. I'm going to do that to you every day until you learn how to multiply. Comes in the next day, Say, Amir, how much is 7 times 8? Say, 52. How much is 7 times 8?
52.
There's the moron again, Mr. Stupid. I do that to him and I humiliate him. By the way, I pay for therapy for this, don't worry. I humiliate him, and lo and behold, after 6 weeks, he knows the multiplication tables. Right? By the way, it's even worse. I get the class, when we get the class chanting, Amir is stupid, Amir. I mean, I got it going here. Right? I ought to pick on it. How many people think, he's been trying to learn this for 3 years, and I finally got the technique to do it? How many people think that what I did is good teaching? How many people think it's lousy teaching? Just about everybody. Okay, so you have a limit too. You're saying I've got to balance crucial knowledge with emotional well-being, right? So we have to be careful about this. And in the end, there are people who will tell you that emotional well-being is all that counts. And if the person is emotionally healthy when he wants to multiply, he'll figure it out. Or he'll be able to come for the aid. They'll even tell you one reason he probably can't multiply is his stomach's so twisted in knots when he thinks about a multiplication that he wants to throw up. How many people are that way about math? You have to take a math course and already you feel like you want to throw up. I'm raising my hand. Right? Yeah. Okay. They're saying that's the problem. If we could get rid of those emotional barriers, you'd be good in math. Okay, let's go back here. And we also have to ask ourselves, how is achievement or the lack of achievement explained? For each theory, we sort of have to ask ourselves, how does the theory define achievement? We're not going to be able to do this with all of them because some of them are emotional theories. But this is what we have to look at. You have to keep this question in mind. What are the factors that contribute to achievement? Both from the point of view of the kid and from the point of view of the person. And achievement means gaining mental health. Achievement means eating better. We got a dietitian in the class, so I'm picking on her. Achievement means being able to function better in society. Whatever your definition of achievement. Achievement means the stuff in school too. And we have to ask ourselves, what are the factors that contribute to the lack of achievement, possibly causing a child to be labeled? Okay? So, I'm through with this. I know we're supposed to do, but we're going to go on to the next one because I get behind on other things. Okay? What we're going to have to do now is look at theories and different theoretical approaches, and frankly, at certain approaches that lack theory. Okay, and we're going to start to do that the second half of this class. I'm going to give you a little insight into that. Wait a second, I'm not done. I have a little tirade here. A little insight into that and what happens when you neglect theory. And what's going on when you fail to use science? And I'll tell you, quite frankly, I'll tell you up front, you get, to my mind, travesties, which is what we have with this whole testing movement. That's what we're going into next. We're going to have to keep our mind on things. And as you do this, remember, just because everybody does it, just because everybody knows that this is the way to do it, doesn't make it right. When I attack attention deficit, say, well, people have been talking about it since 1920. I don't care. People knew the earth was flat for 1,000 years. Okay? Or more. People knew the farther south you went, the hotter you got. You better not go past a certain place or you'll burn up. Well, it turned out not to be true. If you went far enough south, you got freezing cold again. So you have to be careful about these things, and you have to look, and I'm going to try to show you that you have to, in the end, to have your own idea of what you're trying to do, what you're trying to achieve. And it doesn't have to be my ideas. But at least there has to be some sort of consistency to what you're doing and what you're up to. Okay? And if you have certain contradictions, which I do in my own philosophy, I admit it, you have to be aware of them and cognizant of them and try to balance them. Okay, so when we come back from the break, I know in the film, the tape, there's no break, we're going to look into the first approach to psychology and discuss a little bit of its history, which is an approach basically without theory. Okay, we'll start that and then we'll continue it for a long time. I got a lot to say about this. Okay, I'll see you after the break.